Our next presenter, Tim Schwalm, works for ITT Exelis. Tim is a master black belt, Jonah, and he's going to be sharing the story of not necessarily your Lean Six Sigma work and all that, but actually how he took some of the learnings of the theory of constraints project portfolio management solution, critical chain, into helping ITT Exelis work through some of their project elements. So would you help me welcome Tim?
All right, before you leave. Okay. Got it. Okay. Good morning. I've been traveling a lot this year, and the gift that I have this trip is I was able to bring my wife and my youngest child for this trip, and this is a pleasure. I've been out of town a lot, maybe 6 months this year. Mark is the youngest of 10 children. He's 13, and he has 14 nieces and nephews. So we have a pretty large family, and just great for them to be here. I play chess with Mark, and I was reflecting from Monday's presentation where Dee was asking, does anybody play chess? And just it got me thinking about an analogy of how we implemented or started implementing the theory of constraints CCPM. I learned chess when I was about 3 to 4 years old. My mother had a chess board that she put on the floor. It was huge, plastic, and the pieces were about this big, and she taught me how to move the pieces and to play chess. I played it until I was probably younger than 10. I started beating her, then I started beating my dad in chess. Then I started studying chess and entering tournaments. By the time I was 18, I had won a tournament where I actually became a professional chess player. Got some money for it and won the college tournaments that I played in. At that time, I heard a quote from somebody about chess is, first you learn to play chess, then you learn to play chess. And the analogy I have is first you learn TOC CCPM, and then you learn TOC CCPM. You go to the course, you learn how to move all the pieces, you learn how to set up the critical chain, and you get out in the real world, and it's not as easy as putting together those little pieces on a board. And when you start working with people, it gets a little more difficult. So my presentation, it's called Jelly Side Up, and you'll understand the Jelly Side Up in a few minutes. But it's about CCPM in the engineering world. I work for ITT Exelis. I'll talk about that in a second, but we're made up mostly of engineers. In January of this year, we were ITT, and there were 3 parts of ITT. There was a defense portion, and that was the group that I was in. There was a water portion, and there was a motion and control portion. The revenue for ITT was about $11 billion, equivalent to what the National Football League brings in, and it's about 6 times what the European Championship Football League brings in. I'm just saying. I was wondering, in your list of sports, where does chess fall? It's got to be there somewhere, right? The majority of the ITT revenue came from defense. I think 50 some odd percent of it, 54%. So we were a large portion of ITT. Within the last month, I don't know if you saw it on the stock exchange, but we split into 3 companies. We have a defense company. We are ITT Exelis. And the lawyers say I can say ITT Exelis the first time I say it. The next time I say it, it's got to be Exelis Incorporated. But at no time should I ever say ITT Exelis Incorporated because that company does not exist. Our company, we make weather satellites. At Wayne Britz's site down in Roanoke, Virginia, we make night vision goggles. In New Jersey, we make GPS satellites. We have power solutions here in Connecticut. And at our site, we do stuff that I can't tell you we do. This is hard. We do have commercial satellites. We make satellites for, if you ever looked at Google Earth and you've seen the images, We make those commercial type satellites at our site. The system that I'm going to talk about, it's an interdependent system. You'll see the integrated product lifecycle process in front of you. We make a proposal, we get a contract, we go through some design, we go through integrating everything together and shipping that to our customer. But this interdependent system that you see here is what we do. Before us, there's another interdependent system that's feeding us. After us, there's another interdependent system that we feed into. So you can think of feeders and buffers going all the way through this big system until the final product is made. For a SIPOC at a high level, SIPOC supplier, input, process, output, customer, this is what our SIPOC looks like. In the middle is the integrated product life cycle. And then we've got all these engineers that are feeding this system and all the support processes that feed the system. And if you look at the type of engineers we have optical engineers, electrical engineers, system engineers, mechanical engineers. You think of it's just hundreds of engineers at our site, all working on one product that takes about 3 years to make. So when we start our product, when they say go, they snap a line and they say you've got 36 months to complete this product. And as everybody knows, when you've got 36 months to complete something, from day one, you know you're going to be late. You feel like you're going to be late. There's just too much to do. It's a knowledge-based product, which means technology is changing as you make the product. And as you move along, your customer may say, technology has changed so much, I want you to put this in instead of that, and you've got to change things, redesign things. A lot of things are happening, but you're still held to the 36 months. When I came back from New Haven, the person I reported to, who sent me to New Haven, declared, we will use critical chain in every program that we have. And I go, there's no way I'm going to do that. It's just, there's no way you can do that. Luckily, there was for me, there was a program that was having big issues. They were behind schedule. They needed to be done at a certain date, and they were there by schedule, by critical path, they were 2 months behind. If we didn't meet the commitment, there was going to be a reduction in earnings. It's going to affect our cost. The award fee would be affected by 10%. And if you don't meet your contract commitments, further programs that come along, you may not get them. And there was another thing that the management did, which was kind of interesting. Our customer wanted the product so bad on that date that they said, if you give it to us on this date, we will give you an extra X million dollars. But they said, if you don't meet that date, you owe us X million dollars. And they said, we'll take that bet. Tim, go. And I said, whoa. But we did it. You know, we took the bet, and this is what that story is about. In the program world, the world of space, schedule is king or queen. Everything is done for the schedule, and it drives bad behaviors. It drives behaviors where you may complete something and move it along, even though it might not all the way be done. Designs may not be finished before they're moved along because you need to procure some stuff before you think things are going to happen in sequence. You're constrained by headcount. You snap a line in the beginning, you say, this is how my headcount's going to be for the next 3 years, and they hold you to that. So you say after a year and a half, we're going to be up to 400 engineers working on the program. They look at it after 2 years and they say, okay, you've got 420, you've got to get rid of 20 engineers, even though you might need them to finish up. The overall time is measured in years. So we have a 3-year program. The estimates in the beginning, they call it the complete success schedule. Everything is based on everything being perfect all the way through. People try to put in more slack than they need, and I think they overestimate because they know that they're going to be pulled back. And the success is, of course, it's tracked by the completion of tasks on time and on budget. When we brought the critical chain back to our management, there was a process they went through. They said, well, we can continue the critical path with the unrealistic dates and just pretend that we're going to be late. We'll pretend and we'll try to move it forward. They thought, well, if we got additional test equipment, maybe that would help us move it to the left a little bit. We could outsource part of it. Maybe that would help a little bit. They thought maybe we could bring in additional help, but we're constrained by headcount, so we couldn't do that. And they said, all right, Tim, we'll try critical chain. Let's go. The problem statement that I put together was to create a critical chain project management process that will ensure that these box schedules are realistic, manageable, and capable of meeting the contractual requirements and commitments. Now, Ken was talking yesterday about this iterative process that they went through. And this was my first working through critical chain. I thought, well, the first thing you need to do is figure out what the critical chain is. I'm a Lean Six Sigma Master Black Belt. I thought the best way to do that is to work with a value stream map. We'll put the value stream map up on the wall, and we'll do an iteration of that with everybody in the room. So we did a first iteration of value stream map, cradle to grave, including the suppliers until it shipped. Then we did a failure modes and effect analysis on the whole process, cradle to grave. You know, what can go wrong, trying to understand what the distributions of time were for each task. We did a failure modes and effect analysis for the internal process, so as our subcontractors and suppliers brought stuff into the house, as soon as it hit the house, what failures can occur inside? Then we did the internal process value stream map, the second iteration value stream map for the whole process, and the second iteration value stream map of the internal process. What happens between the first and second iteration? When you do a value stream map, you do a current state, you look for all these improvements that you can do, and that becomes your future state. You do that improvement, that becomes your new current state. Then you do another future state. We went through basically three future states of this process, 3 iterations to come to a good critical chain. What did we do in the first value stream map? And this was kind of exciting. We brought in everybody that was working on the process into one room, and we did the value stream map with everybody in the room. We did it from end to beginning, as you do with critical chain. And by necessity, we worked backwards. And we had everybody up on the wall putting up their parts of the value stream. It seemed to me when these people came in the room was the first time they'd met each other. They didn't know what each other was doing. Like if I was handing off to somebody, it was like, hey, you know, I'm Tim, and here's what I'm doing. And they say, oh, well, I'm taking it from you, and here's what I'm doing. So we developed that flow, the first value stream, without the scheduler there. Right? It was, how do you think, by necessity, this is going to be put together? We brought the schedule in and we checked the schedule that they had to the schedule, right? And of course, there were a lot of mismatches, but we also did the first iteration of time distributions. This value stream map, here's one wall of it. We had a room that goes all the way around the wall. Each color designates something different. The yellow is the task. And as you go through the different colors, it's the equipment, the measures, the information flow, all the different things that you would need for a value stream. But when it came to time, for value-added time, I asked each engineer to put up 3 times. The nominal time, which you think is going to be in the schedule, what you put in the schedule. Tell me what the worst that can happen, and tell me the best that can happen. I want 3 times. And I want those 3 times, I'm going to try to identify what the distribution is underlying your task. First iteration, they took their guess at it, and we put those numbers up. And I used them to do a Monte Carlo, and I'll talk about that in a few minutes. But this developed a system. It developed a system. And the system that I'm trying to change is the constraint, which is a critical path, right? I'm trying to fix that constraint. Within the critical path, when we develop the critical chain, there's going to be constraints in there also. So you got the system we're trying to change. And to change the system, isn't easy, right? It's not easy to do. Dr. Deming developed this idea of profound knowledge back in the late 80s. And profound knowledge, if you think about systems theory, which is the middle of this, it's impacted by three different things. It's impacted by understanding the theory of variation, which Dee talks about when we put together the distributions for the critical chain. It's impacted by your knowledge of psychology, and it's impacted by your knowledge, or your theory of knowledge, or epistemology. And it's a combination of those three things which impact the system that kind of the direction that I went to change this. When I think about the theory of variation, those first three numbers, the best, worst, and nominal, identified a distribution of times for that task. That's common cause variation times, right? It's common cause variation times. Systemic variation that's induced, that they remember, that's always been there. And some of the distributions are skewed to the right? Some of them are skewed this way. Some are normal. Some are uniform. If you're doing a test, it's a 7-day test. It's not going to get worse. You're doing it for 7 days. And some are skewed to the left. A good book to read on the theory of variation might be from Schuhart. Knowledge of psychology. Why would I be talking about psychology? When you're trying to develop a distribution of times, different people will give you a different distribution of times based on who they are. An engineer by definition, Wayne and I were talking about this over dinner the other night. When we put together anything, we put contingency in, we put safety in any design. That's who we are. They are not risk takers, right? They are not risk takers. When I took the theory of constraints from Goldratt, I did my first current reality tree, and I came down to the bottom, and the conflict we had is people are doing what's good for them versus what's good for the system. What's in this for me? As you start reading books on psychology, that's what's happening out in the industry today, right? That's a lot of our issues are people are doing what's in it for them versus what's good for the system. We'll get to that in a second. And how about the theory of knowledge or epistemology? Two things drive me crazy. One is somebody tells me, I know this for a fact, and the other one is this will never happen, right? I know this for a fact, and this will never happen. When I'm doing a failure modes and effect analysis and somebody says, this will never happen, I said, let's walk out on the shop floor and see. Show me. And more times than not, it's happening as we walk out on the shop floor. That thing is happening. A good book for psychology usually goes back to Ed Deci. And Ed Deci wrote a book called Why We Do What We Do. And for epistemology, Dr. Deming used to say, read Lewis, Mind in the World Order, but a better book to read for epistemology would be How We Know It Isn't So. How We Know It Isn't So by Tom Gilovich, another good book. So I learned psychology, variation, epistemology, and I'm thinking the systems theory part was really hurting my head, and that's when I came to Goldratt. I said, Goldratt is the systems thinker that I needed to complete this puzzle. So I did the value stream mapping, and we came to a clear understanding of who was responsible and accountable and what needs to be done and by when. We did lean teamwork, looked at the resources, looked for constraints in the resources, and I introduced the critical chain method to them. Now, engineers panicked because I said we're going to use the aggressive but possible time. And they said, well, we're going to make it anyhow. Why don't we just put in the nominal times? Why don't we put in the time that's already in the schedule and just try to beat that? I said, no, we need 3 times from you. I need the aggressive but possible time. I need a 50-50 date. I need a nominal date. That's on your critical path today. And I need the most probable, which you know in the back of your head, this is what you're aiming for. And I did it like this. I said, okay, we're going to do a failure modes and effect analysis. We're going to look at each task. And for the beginning part of this, we're going to pretend that the toast always falls on the floor jelly side up. It never goes bad. Nothing ever goes wrong. Give me that time. there are 4 types of personalities. I teach green belt, black belt, and before we do green belt, we give them this thing called a DARE survey. The DARE survey identifies whether they're a driver, an analytic, a relator, or an expressive. When I have breakouts for the green belt, sometimes I have fun. I take all the drivers and put them on one team, all the analytics on another team, and the relators and the expressive, and have teams like that. And sometimes I mix them up and maybe put one driver in a team and a whole bunch of analytics on the same team. In a 45-minute breakout, session where they've got to come back with results, how long does it take the drivers to come back? If it's one team of drivers, how long does it take them to come back? 7 minutes. How about the analytics? 45-minute breakout, a team of all analytics, they don't get done. They don't get done. The relators come back in 45. The expressives come back in 45, but they're not happy. They're just not happy people. In my world, our management are retired military. They're retired generals, retired colonels, and retired admirals, and they're drivers. And when I talk drivers, on a scale from 0 to 100%, they're the 60 to 80% driver. For the engineers, the space system engineers, they're analytics. They're analytics. And they're not just, not 30% analytic, they're 60%, 70% analytic. They're smart people. And one of the attributes of an analytic is that they will agree with you in front of you. They'll agree with everything you say, and they'll leave the room and do it their own way, over and over again. If you put a driver and a bunch of analytics on a team, you will see that it drives the driver crazy, right? And the relator will just say, oh, okay, yeah, whatever you want to do, I'll do it. And the expressive will have a lot of fun and do it also. They'll try to stay within the time. So I'm dealing with space engineers, right? A bunch of analytics that cannot give me an aggressive but possible time. So I did a failure modes and effect analysis, and we worked through each part. For people that haven't done a failure modes and effect analysis, you look at each task and you ask what can go wrong. What can go wrong? You look at the extent that it can go wrong in terms of severity. Now, in normal failure modes and effect analyses, you're looking, is somebody going to die? Are you going to lose millions of dollars? You know, is it going to be catastrophic? In this failure modes and effect analyses, I put the severity in terms of time, right? How much time is it going to impact us? So a severity of 5 might be, it's going to impact us by 2 weeks if this goes wrong. Severity of 1 might be, we can fix this today. It's just a minimal impact. The next part is the probability that that thing going wrong is going to occur, right? So we're starting to look at probability now, which helps me identify the distribution, right? If it's a low probability but it's way out here, then that curve is going to be skewed out that way. And then the next thing is detection and controls. How soon will I see it, and how can I control it? You work through the failure modes and effect analyses the first time, and the output of that is actionable items to move the distribution that's out here, move that distribution this way, and try to shift it. If the distribution is this way, is find out what's happening here, drive the distribution here. And if it's a normal distribution, reduce the variation and slide it down. Everybody understand that? See what I'm doing? Okay. I say here, engineers understand Monte Carlo. So the first time I did a Monte Carlo, I took the distributions from the first value stream map, did a Monte Carlo, to show them that they have no possibility with the current critical path method, 0% chance of meeting schedule, right? They understood that. They understood that, which allowed them to engage more in this process. We got the critical chain together, removed constraints that were in the system, squeezed it up, and by the critical chain method, it said we could meet schedule. So how do you control that? How do you keep that success going? We had a daily meeting every day, 15 minutes duration. We had 20 people that would attend, including the program manager, but the program manager was not allowed to speak. I wanted peer-to-peer pressure. I wanted the relay race to occur, and everybody know who's coming next and who went before and all, but I wanted peer-to-peer. If it's common cause, I didn't want that program manager to get involved at all. Each day they identified constraints that might be happening, developed workarounds. And on the tasks that were upcoming, they ran dry runs so that they were prepared for when it came to them, they were ready to go. It was an aggressive relay race, and engineers that were there kept adding new ideas. Here's something you might want to try. Here's something we can think about next week. Very exciting. The results of this, both boxes were completed on schedule. After they saw the success, they said, you know, critical chain, we want to use it on other programs. And I'm getting involved now in programs, not when they're in trouble, but before they even start. They're asking me to come in and help them put the schedule together. One of the constraints that people fear is this earned value concept. That we've got earned value, this will never work with earned value. And I think Dee said yesterday, whatever you do, it's better than what you have today, right? But there is a multi-company team. It's led by ProChain, and if you want to get more information on their ideas, talk to people from ProChain. We introduced it into the black belt curriculum as an introduction to the theory of constraints and critical chain, just an intro. But Wayne and I just taught a black belt class last December, and we had a problem that we gave to 2 different black belts. The same problem. One Wayne mentored with a classical Lean Six Sigma tools, and the other one I mentored with the theory of constraints, current reality tree thinking. And his black belt is done, implemented a new computer program, a checklist, number of things. And my black belt is working with HR right now to change reward policies of rewarding engineers for moving things along to meet schedule and not worry about quality. Which one worked with the theory of constraints? The theory of constraint one is working on a systemic issue. Even though Wayne's got a new computer program and all this stuff, the issue still is there. It's still there. People get rewarded for meeting schedule. Other sites are implementing critical chain. In these boxes that were budgeted for $13 million, we spent $8 million to make the boxes. We saved $5 million just on this one process. And we got the incentivization, if that's a word. Lesson learned, after we did this, I went back and interviewed the engineers that were involved. And it was kind of funny because the first one I went to, he said, yeah, it worked really well. I said, do you think we can use this on every program? He goes, oh, that was too hard. That was too hard. I said, what do you mean by hard? He said, well, you know, if it came to me at 2 o'clock in the morning, I had to be there. I had to be there. You know, I've got my whole life was revolving around being there when they needed me. I said, well, that's probably the way work is going to be these days. It only works when there's buy-in from everyone, including the management. The peer pressure, everybody buying in, getting people in a room, having them talk it out. Monte Carlo simulation brings the reality of the situation, and it helps to change the behavior. But I'll tell you, critical chain will beat Monte Carlo every time, every time. I'd come in the morning, and the engineers would see me coming in, and they'd say, Tim, we're beating your Monte Carlo. I said, I hope so. I hope so, because you should be. You should be. Another lesson learned is that the aggressive but possible time is not a 50-50. And even doing the FMEA, it's not a 50-50. It's historically, in people's mind, in our business, things have gone wrong. And people have been accountable, thinking that it's a special cause. Our engineers are rewarded for meeting schedule and not rewarded for being late, so they will always put in that slack. Engineers are analytics, and there's always another idea to try, something that can make it a little bit better. I think the analytic tool of failure modes and effect analysis helps to get them to thinking about the 50-50. And the question is, what if everything just falls jelly side up? I know it doesn't happen, but what if it does? Helps get to the 50-50. That's it. You have a question? Okay.
There we go. And the size of the project, yes. How many tasks are you talking about? So this one, we're already underway. When you were looking at some of the new projects, what's the quantity of tasks that you're dealing with in creating this?
Well, it depends how deep you go in the schedule, right? From a high level, you could probably keep it from a very high level, 90 tasks, but it breaks down to thousands as you work through the 3 years. Critical path schedule might have, I don't know, 5,000, 7,000 lines on it, easy. The other thing I didn't say is when you go through the value stream map, you start talking it out, you remove tasks. You say, why are you doing that task? Well, I know I have to do this, and somebody else says, I don't think you have to do that. We could try to do this. So you remove tasks, you remove time, you start leaning down that whole process.
Other questions, Carl?
Hi, I have 2 questions for you. Is it mostly a single project environment or multi? And how do you handle engineers' self-imposed multitasking?
That's a great question. 6 years ago, it was easy. We had more engineers than we needed, and we didn't have the problem of if you were on my program, you were on my program for the duration of 3 years, right? Your headcount you would stay with me. In today's environment, it's very competitive. Our competitors are bidding lower than us. We're being asked to cut like 25 to 30% out of the cost. And the headcount becomes an issue. So in multiple programs, you may be now, instead of just working for me, you're working on my program and another program and perhaps another program. That resource problem is surfacing rapidly. We haven't addressed it yet in terms of, it hasn't become a big issue, but it's going to be. It's going to be very rapidly. Yeah, we have had 4 downsizings in the last 2 years. And we're becoming lean, very lean. So when we used to have 4 engineers that could do something, we now have 2 or 1. And you may become the constraint for the business, depending on where each program is.
Second question, Carl, was? Got it? Okay.
How do they deal with the tendency to come in one day and think this is hot and this is hot, you're working around?
So the first question was multi-project environment, shared resources, and Tim has answered that that's going to become a growing issue for them. But the second one is, did you do anything differently with regards to the individual tendency to want to multitask anyway, even though you're feeding them some things?
On this program, for this, people didn't multitask. They couldn't. It was critical chain. I actually got a video from a pro chain conference from Raytheon, and it showed the relay race. I don't know if you've seen that little video. And I showed it to the team, saying this is the way we're going to behave. That if you're on the critical chain today, no emails, no phone calls, no meetings, nothing but the work that you're supposed to be doing. Everything else is not part of your job. Your job is this. And they bought into that. Can they buy into it forever? Not sure. I'm not sure. This was our first big exposure to it, our first endeavor into critical chain. And as we progress, as we start learning to play chess, it may change. Right? Become a little more difficult.
Other questions?
Hi. You mentioned that the aggressive but possible durations for engineering isn't usually 50-50. Did that change how you sized your buffers and how you did that?
To size your buffer, you've got to have a really good estimate of what that 50-50 is. I mean, you've got to understand where that's coming from. I'm a statistician, chemical engineer statistician, so I don't like people just giving me numbers. I want to know where they came from, which the FMEA helped me get to. It affects the size of the buffer. You can also do a components of variance to find out where the biggest problem is, right? You could do that. The buffer sizing initially was huge, and as we kept working through the iterations, we got that buffer down to pretty small. Because if you reduce the variability, that buffer just keeps sliding down, right? If you can reduce the risk. So,
Almost a related question. Did anybody beat their aggressive but possible times?
I would say probably half of them did,
Yes.
yes. Which surprised me because this is, I just don't feel good about this. And then they come in early and I did it, I did it, and they move it along. So.
Other questions?
You said a lot of what you do involves earned value as well. Did you run, I want to call them parallel books with CCPM and a separate EV schedule, or how did you integrate the two?
For this project,
Well, so I think
I know what the question is.
I know, but because
Yeah.
there's some elements. Typically, CCPM is a way we're going to manage how people do. EVMS is really giving a tracking of elements of which we need to respond in regard. In some regards, I think Shane was talking a similar issue. They're using CCPM as their management element. Shane was talking about the several tools or TI and OE and how to manage. You still have to report out in terms of all the things you need to be as being a good corporate citizen.
Right.
So at this element, how did your EVMS track?
Well, see, the earned value was calculated from the critical path because we already showed that to the customer. Everything was from that. We ran the business by critical chain.
Anything else? Would you help me thank Tim for sharing his story? Thank you so very much.